Hey guys, so welcome to an Unreal Engine 4 tutorial video. In this video I'll be explaining how to link C++ variables into widgets instead of using blueprints. This will involve using the delegate system that's already a part of the API framework for Unreal Engine. So before I've probably made widgets in blueprints, so I've created my text value. This could be anything. Dropped whatever the value is, in this case it's 0 by default, gone into here, created a binding, and then when I've gone to the function, I've got the game mode, casted the game mode, got whatever the target variable is, so in this case it's a dummy variable called test variable, converted it to text, and then whenever that variable changes it's displayed on screen. Instead of using blueprints, this will literally just use C++ instead rather than converting it. So without further ado, we'll go into the tutorial. Okay, so for my tutorials I'm going to use Engine version 4.22. It's the one that I've just been practicing on, and I feel that'd be the best thing because you're less likely to encounter any errors where the engine version's changed. I mean, you're able to use a later engine version if you like, but for this it's going to be 4.22. So in order to do that, I'm just going to use your Epic Games launcher, click on Library, and then you can either launch from the top right if that was the one, which is your default one selected, and that should bring up the Unreal launcher. Okay, so there we go. So all I'm going to do is click on a new project, go into the C++ tab, and the version that I'm using is the third person template. That gives you basically a ready to go character along with something you can just hit play and you've got something to simulate in with a couple of stock assets. You can decide whether or not to use starter content or not, that's down to you, but for this one I'm just going to keep it lightweight because I'm uploading to GitHub. You can use, let's say if you wanted a different project, you can use the first person one, you can use any of the other ones, but for me I'm going to use the third person template. Okay, with that selected, hit create project and it'll load you up a new template that you can use for the tutorial. So before we go into any tutorials, we need to install the Unreal C++ development tools to our version of Visual Studio. Now for mine I'll be using the 2017 version, but the same process applies for both that and 2019. So all you need to do is click Modify, scroll down to Mobile and Gaming and select Game Development C++. Scroll down again and you'll see Unreal Engine Installer. If that's unchecked, check it, and then all you do is hit Modify, and that will install the tools that you need to develop with Unreal Engine using C++. If you have any problems, check the Unreal Engine community or just type in a Google search the issue you're having, and usually somebody's had a similar issue and they'll be able to provide provide the answer to get things running. When you first open Unreal Engine and you go into a C++ file, it will take a little time to parse all the required files, but all you need to just wait around and then it'll tell you when it's ready. So with that done, let's move on to the tutorial. So the first thing you need to do is add the UMG to this Visual Studio modules list. So to do this, all you need to do is go File, open Visual Studio, and it'll open whatever version of Visual Studio that you're already using. Give it a second to load. And then what you need to do is you need to navigate to the project name .build.cs. Now in my case this is called, my project is called delegate tutorial.build.cs, but yours will be your project name .build.cs. And you can see here I've already added it, but I'm going to just retype it in anyway because it's not going to harm it. What you do is open quotation marks, type in UMG, hit save, and then what I need you to do is you close Visual Studio, close Unreal Engine, go into the project folder wherever your .u.project is, right click on it and click Generate Visual Studio Project Files, and then that should upload all the dependencies for the UMG module. As soon as that's been done, you can reopen your project, and then once that's been reloaded, your C++ Visual Studio should recognize UMG components. That includes all the ports for the widgets, the text boxes, the editable text boxes, everything you need to proceed. So that now we've done that, the next stage is to create the parent C++ class, and this we're going to be using a user widget. This will contain all the logic in order to access the variable that we want to display on the screen. So to create a new C++ class, it can either be new C++ class where you go into File there, you can just on the drop down here add new C++ class, or a simple case of just literally right clicking in there. So I'm just going to right click in there, new C++ class. Now the user widget won't be visible straight away, so in order to find that we need to check show classes. Type in user widget and type next. So what I'm going to do next is I'm going to call it something parent widget. Okay, name doesn't, you can call it what you like, but I'm just going to call it that just for clarity. Create the class. I'll generate new C++ code. Okay, I do apologise, for some reason Unreal decided to crash as I was compiling the code, but as you can see the parent widget's been created, and if we go into Visual Studio you'll now see that we have a header file, and we also have a source file, .cpp file as well. So next we'll create the actual blueprints that we'll be using this. Okay, so now that we've created our parent widget C++ class, the next step is to create a blueprint widget that can inherit from this C++ class. So all I'm going to do is I've created a folder called delegates, but if you want you can add a new folder, create that wherever you want, widgets, however you choose, but in this case I'm just going to use the delegates folder, right click in the folder, in the window, user interface, and then select widget blueprints, and then just as a little bit of consistency I'm just going to call it underscore blueprints, parent widget underscore blueprints. Once that's done, open it up. I'm just going to attach it to the top window as well, and as you can see we have everything in here. It's just a blank canvas, nothing in there, no details. So to parent it to the C++ class, all you need to do is go into Graph, click on Class Settings, and as you can see it's using the standard default user widget, which is inaccessible to C++. However, we've created our own version of that that's going to inherit, called parent widget. So in my case I've called it parent widget. I'm going to select parent widget, hit save, and as you can see it changes up in the top right hand corner. The parent class is now the parent class C++ version here. Obviously there's nothing in it yet because we haven't programmed anything. So the next thing that we need to do is add a text box into the widget, so when the variable is changed the information is changed on the screen. So in order to do this we're just going to go into the Designer tab, we're going to go into the Common drop down, we're going to select text, we're going to drag it onto the canvas. I'm just going to change the text to null, double its size to 48, and then I'm just going to center align it. So in this it's not going to look pretty, it's just going to be a standard text text block that changes once the variable's been updated through the C++. Now that's in place, we will be looking at the logic within the parent widget to change this. Right, for the next part I'm going to cheat a bit with this and it's in regards to the game mode. So what I've done is I've basically right clicked, created a new C++ class, and then I've just derived a game mode from this and called it test game mode. So if I access that in Visual Studio and go into the header file, all it is, I'll just leave this on screen and explain the methods, and then obviously you can pause the video and type them to get them into your system. And I've done the same with the source as well. So it has a default constructor. It's got a U function which is blueprint callable, which is set the score points, which literally takes an integer value and can be called anywhere in blueprints where the game mode is accessed, or somebody's got to get the game modes and casted to it. Another one is to get the score points, and that's another U function, and that just returns an int32 value. It's got a private value, which is the score. This is the value that we'll be looking at when for changing and updating the widget in the parent class. So if we move into the source code, we can see the implementations of all these methods, and we've got the constructor, which by default it sets the score to 0. The next one is obviously the implementation for the set score points, which takes in the integer value, and that's just plus equals whatever the value's been set, and it's just printing a display log out as well, just to say to tell me what's going on in the event log, or the output log, beg your pardon, and not just say, yep, we're just looking, that value's been changed, here's the value. And then the last method is an int32, and it literally just gets the score points, which returns that private variable. Now that the game mode has been set up in C++, I'm going to create a blueprint derivative of this. This will contain the character with the methods to update the score. So I'll go through that now. So all I've done is I've gone right click on the C++ class here, create a blueprint based on test game mode. I've already done this and I've dropped it in the delegates folder, and I've just called it test game mode BP. So what I need to do next is I need to make sure that that's the default mode that's loaded. So if you go into edit, project settings, maps and modes, and then do default game mode, which I've already done, you should see I've set it already to test game mode underscore BP, and then I've set the default point cast to be the third person character. Navigate to that. Note I am using the third person CPP, so your character, if you're not using that template, then yours might be different. It could be the first person character, so keep that in mind to make sure that you use the right blueprints. But in this case, I'm going to use the third person character blueprint for the commands that I want. So in order to update the game mode, I'm going to use the tab key. So whenever I press tab, it will update the score by 1. Get the game mode, cast to my test game mode BP, because that's the one that we're currently using. That's that. And then because we set the blueprint callable function, I'm going to set the score points, and I'm just going to increase it by 1. Hit compile, hit save. In fact, we'll just apply. If you go onto the drop down to save, you having to keep hitting save, just go save on compile on success only, and then that'll say just so you can hit compile then to save time. Go into the main editor map and go into the output log, hit play, and as you can see, when I'm pressing tab, the score is updating because we're calling this blueprint method here. We're passing in the value of 1, and it's basically just incrementing that score, and it's printing that in onto the output logs. So now that's been done, now we can start to code the main body of the parent widget code. Okay, so in this next part we're going to be populating the parent widget header. So if you haven't already, open your Visual Studio by going into the parent widget by double clicking, or just open Visual Studio from the menu. In this case, I've already got the file header open, so let's proceed with populating the code. So the first thing I need to do is add a public method this one will be a virtual void native construct, once we want to override it. Oh, I forgot the brackets. Now this is part of the parent user widget class, so if you need to find this, you can always select that, hit F12, and that'll take you into where that header is. And then if you just go into type in native construct, you'll see it there, virtual void native construct. Okay, the next method we're going to add is protected, and this is going to be a bool initialize, and this will be an override as well. Okay. Now, once that's the IntelliSense is updated, it will come up with a green squiggly line saying that it actually needs definition, but we'll worry about that in a minute, in the next section. So next, we need to start to add some private variables and methods. So the first one we're going to add is a U property. You can always tab to auto complete, type in meta equals open brackets find widget. Now what this is doing is we're actually going to forward declare a pointer to target a specific item within the blueprint widget that we created, and we parented this we parented to the C++ class. So to forward declare, you just normally specify a class, and the item that we want is a text block, asterisk to denote it as a pointer, and in this case I'm just going to call it score text. Now, before I proceed into the other properties and U functions, I need to basically go over why this is important. So I've called it score text in the C++, but if you go into the blueprint and you attempt to compile this, it will throw out an error. So what I'm going to do is, I know that this field's text, which I've just called, which is saying null at the moment, I want to call this the same object as the item that was the forward declaration in C++. Hit compile, and then hopefully that should map to this forward declaration without any errors. So next one, I want to add a U property. If it allows, you can always just select in this tab a U property, and I want to, oh beg your pardon, U function, beg your pardon, I need to add a U function. And this is going to be an ftext set score field, and it's not going to have any input parameters. Okay, and as you can see, it's finally updated, and the IntelliSense has picked up that you need to create a method. So that wraps up the header file for now. So if you want to pause and obviously at this stage and just copy these methods across, and then I'll join you in the next section. Okay, so now that we've populated the header file, it's time to populate the CPP file for the parent widget. So first thing we need to do is we need to add the first method, which was native construct. So got uParent widget, it's native construct. And this will contain a call to super, which calls the base methods from the base class. And for this is not going to have any more code in it. The reason I'm leaving this blank, because there's actually going to be something, this is going to be used in a future tutorial video separate to this. So next we need to populate the initialize methods. Now you can shortcut this if you go back into the header, right click on the initialize, quick actions and factorings. It'll come up with at the top option, create definition of initialize in the parent widget CPP. Do that, hop over to it, and as you can see, it'll create the method for you. Now what I need is full success, and I want to make a call to the base method of initialize, which returns a bool. Okay, if this isn't successful, return false. So the next thing I want to do now is I want to check if we have a valid score text field. So if we go if score text, open parenthesis, and just for debugging I'm going to use the log temp that will display a warning message to say if that method's been accessed. And this one. Okay, so next stage I want to basically find the game mode. So to do this we're going to access the world, which if you look in the actual parent user widget class, you can see there's actually an interface that can get that. So that method is included as part of the user widget, which we inherit from. So we're going to do that now. We want to pointer at the world, and we're going to call that method get world. And I'm going to do a check now. If world is not null pointer, then we're going to cast to our test game mode. So if you remember in the previous section, I called my class test game mode, but for some reason it's not appearing, and that's because we need to add the include the header so that it recognizes it. So type in test game mode, and it should say resolve the IntelliSense. And then what we need to do is just cast to the a test game mode, open brackets, and we're going to get the worlds that we called in the previous methods, and then we want to get the authority game mode. If that game mode is there, I'm just going to do the same thing. In fact, to save time, I'm just going to copy this rather than spend time. Game mode. Highly useful to use the these log temp warnings, because it can basically tell you where the process is if you don't want to do it via breakpoints. So next thing I'm going to do is score text, set text, and say ftext from string, open brackets, and I'm just going to say there we go. That's why. Okay, reason why we've not added that is because we forgot to include the actual include. So what we want is components, and we need an actual text block, because we forward declared it in the header file. Here we actually do need to include the components header into this, so that we can actually set it so it knows what a text block is. In this case we've called ours score text, that's a text block, and then we're just adding it there. So that's found it, that's solved the IntelliSense. Now this is now where we're going to set the delegate. So within a score text box, we have this text delegate. Now, if you remember what we were talking about at the initial intro to the video, this is the same thing as this binding here. So instead of clicking bind and creating a binding, get rid of that. All we're doing now is we're just accessing it from C++ as well to save having to use blueprints. So what we need to do is we need to bind to U function. Obviously this is the object we're setting it to, and this is going to be set score fields. That's the method that we called, if you remember, in the header file. Quickly save that, and then next stage we're going to create the actual method. So jump back into the header file, refactor that by right click, create definition of set score field in parentheses CPP, parent widget CPP, beg your pardon, and then we're going to create the method for that. So do understand that this is a lot of codes, but if you bear with me, we'll almost get to the end of it. So get the word again. If world is not null pointer, open parenthesis, and we're going to cast to the game mode the same as things we did before. So effectively we can just literally copy some of the code from above and paste it in there. If you missed anything, don't worry, I will be uploading this copy of this project to GitHub so that you can compare notes if you need to. So as this method is returning an ftext, we need to, in each parenthesis, tell it to return an ftext. So from string, fstring, from integer, bear in mind that the variable that we created in the game mode is an integer, and we want to get the score points. Okay. Oh, missing another bracket. There you go. Okay, if that's not valid, then if we don't have a game mode, then that will return just another ftext from string, and I'm just going to return null. For some reason, if there's no game mode, that should never hit, but just to satisfy what this method requires, and it needs to return an ftext, we're just going to let it return something. And then if it gets down to here as well, I'm just going to make the same call. I'm going to go return ftext from string, I'm going to return null as well. Okay, so what I need to do now is hit compile, and then hopefully that should be okay. Okay, the code's compiled with no messages in yet to say that it hasn't, and if you just quickly go into the output log, you can see here that it's actually got score text found, so it is in effect running this code here on the initialize. Obviously it can't go into the world yet because there's no world being created, and certainly there's no game mode, so that's a good sign. So in the next video we're going to add the widget to screen, and we're going to test to see if this works by using the tab button. Okay, so the last thing we need to do now is add the widget to the screen and test to see if the binding has worked. So all we're going to do is open your third person character, whatever character you're using, with this function, the tab function in, and so we're going to get the player controller, right click, create widget, connect owning player to the get player controller node, and in this we're going to literally set the class as the parent widget BP, and then we're going to add it to viewport. Hit compile, go into the first person example map, we're going to hit play. So the widget appears on screen and currently it's set to 0, which is the default in the game mode. Press tab, that amount's incremented, and as you can see I'm hitting tab and that amount's also appearing in the widget display. So effectively we've replaced the old school binding system in text and we've done it in C++ instead. And all we're doing is we're just using the already assigned delegates within the API for that particular object. Thank you for watching my video, and if you like what you see, please subscribe and like, and feel free to leave a comment below if you have any feedback or suggestions. Take care guys, goodbye.